So back to North Queensland, Northern Australia, and just to start, I work for James Cook University and the Water Centre, and we specialise in translating science for action, the theme of this conference. There's about 20 of us work there. We've been around since the early 80s. Just note that I'm giving the talk, but this is Alex Carter's work for cities purposes. The old white blokes have got here to give the talk yet again. Okay, so you've heard this before, and I'm going to say it again. It's not just about coral. We hear so much about the Great Barrier Reef and about its coral. The World Heritage Area, which you can see there mapped out, covers about 350,000 square kilometres. Of that, about 10% seagrass and only 6% is coral. There's more seagrass in the Great Barrier Reef than there is coral, and without the ecosystem services that seagrass provides, it's unlikely the coral will be in as good a condition as it is. Ironically, if you look at the meadow here, we take about 2,000 tourists a day to look at some very poor coral on Green Island near Cairns and some pretty fish. But if they turned around, they would see one of the most impressive meadows that you can get. This is Green Island just near Cairns in Queensland. So some very, very good seagrass meadows aren't really being appreciated as they should. But today I'm going to take you back briefly into the 1980s. So we started doing our seagrass research in about 1981, funded by the fishing industry, who were keen to see what their prawn shrimp nursery grounds were doing and where they were. So for those of you who weren't even born or perhaps working on seagrass in the 1980s, it was a very different world. We didn't have an Abby Scott to tweet to managers what you were doing as you were doing it. We didn't have an internet, we didn't have personal computers, we didn't have GPS. If you wanted to work on seagrass, you had a compass and a map. And so our precision was much less than it is today. And I've just got one of the maps there from our early work in the 1980s, and you can see the seagrasses there marked on the map, little smudges with a little sticky stuff called dataset, and it was only in a book form. If a manager wanted to look at your research, they would have to get that book off you or come and talk to you. So it was very much different back in those days. Our position fixing was different, our ability perhaps to identify seagrass was different. So understand the world has changed a lot since then. So fast forward then to the 1990s, we started to become much more involved in the management issues of the Great Barrier Reef World Heritage Area. They rezoned it in 2002, and our data was used extensively in that. The questions are still the same then as they were now. You know, where does seagrass grow? Where isn't it? How much is there? How's it going? And how can we monitor change? I've just got from one of our publications in '93 the sort of graphs we were or figures we were producing for management back in those days. You can see just how awful they were. It's cringeworthy looking at them now to think that a manager would even bother to read a graph like that. And given back in those days, if you wanted to get a library copy, you had to send a card away and wait a couple of weeks for a photocopy to come back or an author to send you something. So it wasn't manager friendly. It was very much science-based. And about that time, Len McKenzie, who's our secretary of our World Seagrass Association, came to me and said, "Rob, you've been around a while, you're getting old and grey, and maybe we should make sure that that data from the 1980s is put in a form where we can use it." So Len and I set about going back to all our old data sheets and coding the original data in a way that made sense and lifting it up onto a digital platform. So it was published as a set of CD-ROMs, compact discs, and that covered all the original data and put it in a database that was basically it was MapInfo, not ArcGIS, but still available. And that was used to then identify dugong protected areas where there were seagrass meadows and help in the rezoning of the Great Barrier Reef. But it wasn't until Alana Gretsch, who gave the plenary on the first day, came to join with us that we really started to understand the value of a digital data set. Now, Alana took all our data, not just what was on the CD-ROMs, but data we collected as part of industry projects, and patched it all together, stitched it all together, and she was able to produce information we could use at the scale of the Great Barrier Reef. For the first time now we could talk about the Great Barrier Reef seagrasses as a whole. So just over on the left-hand side, she did some simple things for us. She just mapped out the probability of seagrass being found anywhere in the Great Barrier Reef, which gave us some very good information about the spatial discontinuity down the coast. We get these very big areas in the north with low probability because there's just not a lot of nutrient input, clear white sand. In the middle of the wet tropics, we get almost a tap drip effect with nutrient flows from the land. And down the bottom, where there's not much seagrass down the bottom, we have 8-metre tides, so enormous bed stress, so you don't get a lot of seagrass in those areas. But then we realised how powerful that was, and we started asking some really serious management questions. At the time, the trawl fishery was getting a lot of bad press, and for good reason, because it looks awful. But it's also very productive and a very valuable fishery in our part of the world. So we used Alana's experience and spatial analysis skills to look at how trawling overlaid the seagrass meadows, and we were able to point out that where they were allowed to trawl, most trawls were only fishing, most pixels where there was seagrass were only fished around about 1 time per year. So 5% of the available area was only fished once a year, but almost a quarter of the shrimps, prawns came from those pixels. So we're able to overlay the trawlers and where they fish. They all have transponders on them these days, so you know exactly where they are, against the digital database of where seagrass should be. So a very powerful tool to sort of say, well, the trawlers aren't really, it looks awful, but they're not really having a big impact. So the value of that tool started to become really clear to us. Move forward then to 2014, and again, one of the problems with the data set we had is it's still only available to us. So we looked at the modern sort of way the world works and said, well, we should make this data available for everyone to use. So Alex took the lead in doing that when we went back and revisited all those old data sets yet again and shifted them up onto an ArcGIS platform. And then I was sent off to write letters to everybody we worked with. So a lot of industry had supported our funding. And we wrote to them and said, do you mind if we take your data and give them to everybody? We'd like to make it available. And almost everybody said yes, and that included CSIRO, one of the big data set holders, who were able to add into our data set a massive seabed biodiversity data set. This is now available for you to use. So if you go to eAtlas, I've got the websites down the bottom, or you can just Google eAtlas, seagrass and carter, you'll get to a web page where you can either use the interactive tools on that website, or you can download by zip all our data from the last 30 odd years and do with it what you like. It's under a Creative Commons license, and we'd really appreciate if you talk to us before you use it, but it's publicly available. What's in that data set then? There's 350 spatial data sets spanning 30 years in the GBR, and there's also a Torres Strait data set, the islands between Australia and New Guinea. It's collected by a variety of organisations, you can read that yourself, and it's collected by a variety of methods. If you go to the right hand side, just for your information, I've shown you how we used to do it back in the old days. At the top, the modern scientists sit in a helicopter with a laptop in their laps and drop a quadrant. They don't get muddy unless they have to, but that's because they're probably a bit brighter than we were. What does that look like then when you look at the data? So I've just got a couple of examples. So this is the site layer for the GBR. There's around about 66,000 data points in that site layer, covering 12 species. And just at a very simple analytical level, you can see that if you swim down in the Great Barrier Reef, it's likely that you will see seagrass at about 40% of the times you hit the bottom. No, it's not random, but the 3 big data sets that underpin that data layer were all collected randomly with a constraint, so you can be fairly sure that that's an accurate representation, and given the number of data points, it regresses to norm anyway. Torres Strait's the same. We have 9,000 sites. We've not been working there quite so long. Slightly greater hit rate, and that data set also demonstrated to us we had a gap up in the north. Alex has subsequently mapped that area. It's just not in my slides today. But it's much shallower in the Torres Straits, but you can see discontinuities. The seagrass is very much to the western side, very little seagrass over on the eastern side. That has implications for management and for dugong protection. Then you can look at that through time, which then doesn't look quite so good. So this is separating. We're already at 1990. You can see there was a gap. We didn't do much in the early 90s, and then we came back and did some big deep water surveys. You can see them there. So you can search the database through time, and this is really powerful because it's very easy to produce a map of seagrass and assume it's all the same age. And what happens is it looks good, but people say, wow, you've got really good maps of the Great Barrier Reef. But you've got to remember that some of that data is 40 years old. And we can also, I think I didn't do this animation myself, so I think I have to click on it. You can also look at it by species. Did that come up? It's not going to change. Come on, you can do it. There it goes. So you can also search it by species. The green's pretty well Zostra, the orange is Holophilus. You can see how Cairns Harbour, where we live, changed through the time. We've been monitoring this every year. So very powerful ways. You can just, there's a simple online tools, by the way. You don't have to be a GIS specialist to do that. We can also overlay it against, so Alana did some risk mapping for us. You can read that in the paper there, Gretsch et al. 2011. We can also overlay things like data points over areas of concern and see, off Cairns we've got plenty of data points. Move north to Port Douglas, a little red spot just north, and very little data points. So we can look at how our data distributes. And Alana, in her plenary, talked about the very sophisticated network modelling we've been doing. That's still using an older data set. We now be able to bring in all the new data, and the modellers tell us we can now expand that data and model at the scale of the Great Barrier Reef, which would be fantastic to look at connectivity at the scale of the Great Barrier Reef. Just to finish then, the data's freely available. You can download it yourself, but do remember, metadata tells you what's there, it doesn't tell you what's not there. So you really do need to talk to us. You get into trouble if you use it extensively without dealing with us. But it's Creative Commons, it is available to use. Just acknowledge us. I just want to finish up though, and the final author on the abstract is Norm Duke, who's a mangrove specialist. And if you read my abstract, you'll know I talked about ecological surprises at the end there. So late in 2016, we had a massive mangrove dieback in Northern Australia. We lost about 100 square kilometres of mangroves in a couple of months. It was just a combination of incredibly hot weather. We hadn't had any rain, so there was no water supply, fresh water supply, and some high pressure systems came through and dropped the sea level slightly, and the mangroves died over a huge area of the coast. If this had been around Cairns or in the Great Barrier Reef, it was actually in the far north, which is pretty inaccessible. This would have been a national disaster. And it would be a disaster for seagrass if it does happen on the east coast, because the sediment that mangrove forest holds has started to erode. And I'll just run, I think it'll just start up. Yes, it'll just run. So you can see the sediment started to move. The point I wanted to make is that you assume that climate change is happening slowly. It's 3 millimetres of sea level rise a year, a little bit of temperature change every 10 years. You don't expect there to be a sudden failure of ecological systems, but in this case there was over a massive area. These are 200-year-old trees. This is not just an ephemeral forest. And it's really quite depressing to go and have a look at it. But the advice for seagrass scientists is that sediment movement will kill seagrass meadows, and we could all of a sudden lose vast areas of seagrass. We need to be able to provide advice quickly, and we need to be able to provide it in a way that managers can use. And perhaps the other point is too, and we need to remind everybody that adding energy to the system, increasing the temperature, drying out the continent is going to eventually lead to a catastrophic change in our coastal environment, and we need to make sure our managers are prepared. Thank you.
Thank you, Rob. Any questions?
Good talk, no question.
Thank you, Rob. This is a very nice presentation and amazing amount of data that you have. One question, this data is part of the coral reef sampling or is especially that you have done for seagrasses? And then the other one is if you can link this to disturbances on land, if you have data for development of land?
So the data sets are only seagrass data sets, and they're generally 2 years behind because most of the organisations that pay us to research don't want their immediate data published for people to use. It doesn't include some big data sets, so it's only spatial data, it's not monitoring data. There are data points in there. And to answer your question about off the land, Alana's mapped out the risks from land in this marine policy, I think 2011, and looked at how that interacts with seagrass. Both the seagrass is actually there and a modelled version of the seagrass as to where it should be. So we are looking at that. I mean, there's a very we did that risk assessment work after Banfield, and we asked, I don't know if you know, we asked two questions. We asked at Banfield what people thought were the biggest risks. Then we asked people to break that down in a systematic way in a later survey. We asked them about scale, replication, resistance, and the factors that make up the risk. And when we did that, when we just asked people, it was all about dredging and fishing. When we asked people to do it systematically, those big impacts like runoff from the land, with the big scale impacts, become much, much more important. Industrial, urban industrial pollution, which people grossly underestimate, just covering an area with bitumen and houses, you know, changes the salinity regimes and the sediment regimes enormously. So those things came out. Back in those days, though, we didn't ask questions about climate change. So I think if you asked that same survey now, you'd have a much bigger climate change impact. People would start to worry more, as I would, about, you know, these sudden heat events that you know, could actually be quite big tipping points. We don't know how far they are away.
Yeah. Thank you, Rob. We need to move to